Now I try to explain you these practicals. So these practicals, how the loss of gravitational potential energy of a rolling ball depends on its initial height. How the loss of gravitational potential energy. So gravitational potential energy means what? That is, I explain you. Just you consider there is no potential energy. Okay, there's no potential energy, there's no kinetic energy, there's no energy. You consider likewise. Now I lift this marble certain height. It has some energy. How it comes some energy? Because against this gravitational force, if I lift means gravitational force acting downward direction, gravitational force is pulling this marbles. Against this gravitational force I give extra force. Suppose downward it is acting, just consider 2 Newton force is acting downward. If I want to lift means how much force I want to give? 3 Newton force if I give, then only I can lift extra force. Then if you want to lift more means I want to give extra force 3, 4, 5, 6 likewise. So how much force I giving extra to lift up this marble? That is stored in the here potential energy. That potential energy we are calculating mgh. How much mass is there, how much height is there, and the gravity, how much gravitational pulling force, how much is there. So that is we will calculate. So how we can calculate? Suppose pulling force how much, that means this marble mass is 0.2 gram, you consider. Suppose how much force is acting means 0.5 into 2, not 2, 10, it is acting 5. So 5 Newton force is acting downwards. So in this way we can calculate. So gravitational force is acting likewise. Okay, this is called a gravitational potential energy. Suppose now it is gravitational potential energy is there in this marble, because I lift some certain height. Now it is gravitational potential. Against gravitational force I gave extra force. That is why it is has some gravitational potential energy is there. Suppose some elastic rubber is there. Against this I pull it to the rubber band. Suppose against this rubber band I giving the elastic potential energy. If I lift the rubber band means this is the elastic potential energy is there. So in this way it is gravitational potential energy, because against gravity I keep it some certain height. So it is has some gravitational potential energy is there. How this gravitational potential energy is lost, that is we will see in these practicals. So next, what are the material needed? So two stand, 2 bosses, 2 clamp, 1 marble, there is a marble, 2 rigid runway of approximately length 40 centimeter with V-shaped groove. It should be possible for a marble to roll easily along the groove. 1 meter scale, there is a 1 meter scale is there. Axis balance we have. I show you here the 2 stand is there. There is 1 stand, there is another 1 stand. 2 stand is there. 2 bosses. So there is the bosses is there. There is also the same bosses is there. So clamp is there. So marble is also there here, and also the rigid runway approximately length V-shaped. There is the V-shaped rigid runway is there. Here the ball is rolling here. Then 1 meter rule. There is a 1 meter ruler. The scale is there. Then axis balance. There is the axis balance is there. So the aim, the determine the gravitational potential energy of an object and the efficiency of a system. Efficiency of a system means, so there is the potential energy is there. So that is the efficiency. That is the system. Here there is a aim. So next theory. So when an object mass m at a height above the bench, the gravitational potential energy is given here. So certain height we are keep it this marble. At the time we can calculate using this mhg how much mass is there. So this marble mass how much, then gravity we know 9.8 meter by second square, and h how much height is there, then both we can multiply, that is the energy, the potential energy is there. So in this way we can calculate. So afterwards, if the object at height h1 before collisions and h2 after collisions, before collision means, so there is a v shape growth is there, likewise we will put h1 here. So after that we release, then it is moving here, then it is raised another slab. So how much height is there? So when we take reading, at the time you can understand, that is the h2 we noted, that is the after the collisions. So the efficiency, how we can calculate mh2, how much the initial velocity mh2, otherwise final velocity, that is the collisions after the collision mh2 by mh1, we can divide h2 by h1. So because m mass is same, g also both is same, so we cancel each other, h2 by h1, how much h2 is there initial velocity, then how much it is raised up, that the slab, that is the h1. In this way we can calculate. You see this diagram, in this way we can arrange. So first you see here there is a h1 is there. So h1 is the, you consider there is a initial velocity, initial, just I keep it here marbles. At the time what happened, it is be roll and it is move, it is goes back, here it is raised, it is climb here. So at the time h1 how much height is there, h2 how much height is there, then we can calculate here h1 how much height, so h2 how much it is raised up here in this slab. Okay, h2 you note it. So again the same height you put it here, then how much it is raised, then h2 again the same, h1 is the same, again h2 how much is raised, the h1 is the same, again h2 how much it is raised. After that you can change h1, then you note it likewise. Afterwards h2 average, so 3 value you are take. So 3 value, suppose h2 is 8 point something, means 8 plus 8 plus 8.2 8.1 8.3 means you both you take average, then you write down here, then h2 by h1, h2 is 8 by h1, suppose 11 12 means you write down, then you divide, then east how much east you can get it, h2 by h1. In this way we can calculate this one. So now we will take reading. Now I am taking reading. So first is the, according to your table, h1 in centimeter. Clearly have you seen? So it is inwardly, there is a table h1 how much is there, we can note it. So there is a, I keep it here. Okay, how much height is there, I will measure here. Height is 16.5. So first reading, height is h1 is the 16.5. Here I keep it here. Okay, 16.5. Then I slowly, so here I note it here, mark it. Okay, now I take it here 16.5, then I keep it here, slowly I release, it is reached here. Okay, so this height how much, so I will measure, this height is how much, there's this line is there, that line it is comes around 9.5. Okay, then I write down here H2 is a 9.5. Then again I keep it the same height, the 16.5. Here. Here, how much height is there? Here height is comes 9.8. So second is the 9.8. Then third reading, then I take it. We cannot change the marbles. No. Here. It is comes around 10.5. So what reading you are getting, that is you write down. H2 is the 10.5. Now you take average. Now we are taking reading. The H1, the initial height is the 16.5. After first reading it is comes 9.5. Second reading it is comes 9.8. Third reading it is comes 10.5. So here H2 average, only for we take H2 average. H2 average, what is this? So there is a 9.5 plus second reading 9.8. So 9.8 plus 10.5. 10.5. So average. So if you add up this one, we can get it 29.8. So average means we divide by 3. So divide by 3. Then we can write there is a 9.93. It is comes. There is a 9.9. I write likewise. So after that H2 by H1. What is the H2 value? 9.9. Okay. So 9.9. H1 value by 16.5. 16.5. 0.6. So ratio is 0.6. So how much it is lost? 0.6. From compared to H1 16.5 centimeter means it is a 9.9. How much ratio is there? H1 to H2. That means 0.6 ratio is there. How do you understand? So suppose 1 is to 2 means there is a H1 is the 1. The H2 is 2 means the 1 times is extra is there, H2. The similar way, there is a 1 time is extra is there, 0.6 centimeters extra is there, H1. In this way, we can understand this one. This is the table. Suppose if you want to find, you change the height, then you will do. So after that, interpretation and evaluations. So that means this much it is losses is there, 0.6 times it is a gravitational potential energy, it is losses is there. So this is the loss of potential energy, loss of gravitational potential energy. I hope you are understand something. So after that, interpretation of evaluations. Learners should consider how reliable their measurements are. How reliable, that means how we are taking that reading, it is we are take correctly this reading, otherwise it will be changes, then we will note it. So because if I keep it some 16.5 means, then it is sometime it is 16.6, I will keep it 16.7, I keep it, likewise it is changes is there. So first you believe it is be correctly is there or not, you want to check it is reliable not, that is we want to check. Then second one is the runway might move between the readings and therefore will not be lined up correctly. It is lined up correctly means that marble it does not go straight line. Suppose it is bent like this, it is crossly, it is moving like that. So at the time also reading will affected. And third one is the measurement to be the bottom of balls is difficult. So we take the bottom of ball. So where it is there reaches from here down, we can take that how much height is there. It is too difficult. So graph could be draw of h2 by h1 against h1. So x-axis you write down the h1. So y-axis you write down the h2 by h1 value. What is there? That is you write. So here only one reading only is there. Then you write down there is a different h1 and different h2. You can write like this. Then there is the slope further investigations. So the learner could be repeat investigations the runway, the line different angle, or use the marbles with different masses. So different angle and different masses. So different angle means you see here. So this is the angle. So you can little height, then angle will change. Then it is also little height, then angle will change. Then you do marbles, how it is going, how it is moving, how much height is there. That is you calculate when height is raised. Okay, in this way you can do this practicals. I hope you are all understand something about these practicals. So next there is a practical is there, the same procedure. So there is aim is how the loss of gravitational potential energy of a rolling ball depends on the initial height. The same things they are giving here, the same reading. Then you note it, the same thing you do. Okay, so thank you.